So this video is here to point out the idea of relative velocity. You see, to be relative means you need something to relate to, a reference point. So whether or not I'm stationary right now or not depends on, well, what I'm comparing myself to. Because compared to this table that's in front of me, I'm stationary. But compared to, I don't know, Mars, I'm not, because I'm sitting on the Earth as it goes around the sun, and I'm moving the whole time. Simpler example, if you're sitting in one of these cars, you have this fancy purple wooden sports car. If you're sitting in this car and it's moving at 50 miles an hour, are you stationary or are you moving? The answer is, well, yes, both, depending. If you're sitting in this car, compared to the inside of the car, to someone else in the car or the cup holder or whatever, you're stationary, right? But compared to a tree on the outside or an observer on the outside of the car, you're moving. See, you can be both at the same time in physics, and it really don't make a difference. It's all relative. In fact, Einstein's relativity is based on this concept. So, relative velocity is when you start to when you have multiple possible reference frames. So, for example, an example I just gave you, from the reference frame of the car, you're stationary. And you, compared to the steering wheel, the cup holder, the person sitting next to you, in that reference frame, you're stationary. In the reference frame of, say, Earth, the outside, quote unquote, you're moving at 50 miles an hour. So really it depends on what kind of reference frame, which reference frame you're going to talk about. So that's the fundamental issue here. Now, let's say you have two cars. If they're both moving at 50 miles an hour, what's the relative velocity between them? It doesn't have to be 50 miles an hour, right? If they're both moving at 1,000 miles an hour, right, frontwards or backwards, if their velocities are the same magnitude and same direction, right, what's the relative velocity between them? Well, the answer is 0. Compared to each other, they're not moving. This distance doesn't close, does it? They're not getting closer or farther from each other, so the relative velocity between them is 0. You could, in that case, they're moving together, for example. What if the purple car is moving faster than the pickup truck, the blue pickup truck here? So even though they're both moving, the purple car is moving faster, there is a relative velocity between them. All right? This distance is increasing at an amount. Now, if this is moving at 50 miles an hour and this is moving at 55 miles an hour, as they drive down the road, how fast does this guy see this guy pulling away? In other words, what's the relative velocity between them? So we said this was 50, this is 55. So if he passes him going 55 miles an hour, 55, and this guy's going 50, he's not going to fly past him, is he? Right? It's going to be a relative velocity of 5 miles an hour, even though they're both moving. Right? So the relative velocity between them is 5 miles an hour. Look at it another way. Let's say this is the slowpoke. He's going 50, and this one's going 55. That means the blue one is approaching the purple one at 5 miles an hour. If he's not paying attention and they're on the highway and he bumps him, he's not going to bump him with a force that would be the same as if he was going 55. He's actually going to hit him with a force that would be equivalent to what would be as if this guy was stationary and he was only going 5, right? Because if he's going 50 and he's going 55, the relative velocity between them is only 5 miles an hour. So as they move down the road, I don't know if I can do this great, obviously it's not 50 miles an hour, but as they move down the road, the blue guy is going to be moving closer to him, but notice it's not this, it would be that. I'll give you another example. In fact, this is one of my favorite examples. So I don't know about you, but I just absolutely love escalators and those people movers at the airport. You're at the airport, you got really long distance, and apparently Americans can't walk, so they put these like flat escalators that you walk on. Now, you can go on them and walk in the same direction. So if the escalator has a relative velocity, the floor thing that moves has a relative velocity of 2 miles an hour, and you can walk at 3 miles an hour, then when you get on that thing and you walk, you go at 5 miles an hour. If you stand still, you go 2 and you just get fatter because you're not exercising. But now you know you want to do this. I've done it. You know you want to do it. Some airport in your lifetime, you're going to be there, and it's going to be late, no one's going to be around, or really early in the morning, and you're going to be halfway on one of these things, and I'll be extremely disappointed in you if you don't do this. So if that thing's moving this way, you know. If you turn around and you face the other way and you start walking, you can, if you walk with 2 miles an hour that way, and the floor thing is moving at 2 this way, see those velocities relative to the handrail. Handrail is going to look at the floor thing, say it's going 2 that way, and it's going to look at you and going, you're 2 that way. So, yeah, you're just going to stay right there, right? It's fun, I'm telling you. If you haven't done it, you're really missing out. Video games, nothing. Walking up an escalator, down an escalator, and just staying in place, greatest time of your life. I'm telling you. If you think it is, you're a physics person. Hate to tell you. So, velocities are relative. You got to know what it's relative to. It's important if you're reading a problem to know, well, who's doing the looking here? All right, whose reference frame am I in, or am I considering this all from? Because if 2 cars pass each other, right, then if you pass a car, and it's not really going backwards, right? But compared to you, it's receding because you're going ahead of it. So, but it's not really moving backwards. Someone on the outside in a different reference frame would say the car you just passed is still moving down the highway pretty fast. But from your perspective, your reference frame, that car is actually going backwards, right? You're passing it. It's going back there. So, velocity is relative. Keep that in mind. All right? You can be stationary or moving. It just depends on your frame of reference.